Today we are going to study the relation between the mathematics and the physics. But before we do this, I need all of you to get your copybooks or take notes and write this chart, KWL chart. What do you know about the relation between the math and the physics? How to express or how to use math to express the concepts in physics, and W for what do you want to find out, and L for what I learned. First, we have these three concepts or three essential questions. We are going to answer them today. Why do scientists use the metric system? And we are going to define what is the metric system. How can dimensional analysis help evaluate the answers? How do you evaluate the answers, and how do change or convert one value or one unit to another unit? Mathematics and physics. Scientists or physicists, they use language of math to express their ideas, to express their theories, and to express their quantity. For example, if a scientist needs to experiment something, for example, he needs to experiment gravity or the weight of an object. How can he calculate the weight of any object? He will apply a mathematical formula, which is weight equal mass multiplying by gravity acceleration. So we are going to write here, the scientists use the chemical formula to express their ideas now. And the chemical formula is a mathematics or an example of math. So weight equal mass multiplying by gravity acceleration. Then he's going to substitute by a numerical value, which is 10 kilogram, for example, multiplying by 9.8, which is constant number for the gravity acceleration, it will be 98. How can he define that this is the value for the weight? He's going to use the metric system, or he's going to use a unit. It's called Newton. So now the physicists, they express now the weight value by the mathematical formula mass multiplying by gravity acceleration, and they can calculate it by this steps by substitution 10 kilograms multiplying by 9.8, and then they will write at the end the unit. So this is how the scientists now identify or define or use mathematics to express their theories, to express their experiments with the numerical results to support their conclusions. Scientists also, or physicists, they use or they write, as we wrote at the end of the mathematical equation Newton, so they use some base units. If you are in a scientific community or conference, how are you going to express the value for mass? You will say that the mass of an object is 10 kilograms, or the time that you took to travel to the conference is 900 seconds, or the distance between your house and the conference is like 10 meters. So now you will use some base units here. They gather them in one table, and it's called the system, the metric system, or the system international units, SI. So the SI system of the measurement uses only 7 base quantities, which are this one, length and the unit meter, mass, kilograms, time, seconds, temperature by Kelvin, and so on. So these 7 units, they are the base units. All the other units that we use, they are derived by them. For example, I need to get the speed. We know from before that speed equal distance over time. So if I'm saying that calculate the speed of an object covered 100 meters in 1 second. So you're going to say it equals 100 divided by 1 second is 100, and the unit will be meter per second. So the unit for the speed now, it's not a base unit, but you derived it from the base unit. You got it from the base unit. So this is how physicists use the metric system to express their values or quantity. But some units are too small to be written in like meter or second. So they use like the distance or the radius of the atom. The radius of atom is too small to be written in a unit, centimeter or meter or kilometers. So they use the unit picometer. So to write this unit, we need scientific notation, or we can change it to the base unit, which is meter here. And these are some scientific notation for some prefixes that are used to change the SI base unit by, or we change it to powers of 10. Like femtosecond, if I need to change from femtosecond to second, I'm going to multiply it by 10 power negative 15. From picometer to meter, I'm going to multiply by 10 power negative 12. We have an example here. Convert the speed unit from kilometers per hour to meter per second. How can we change it? We can use different ways, but the easiest way, we have to define first. Kilometers has how many meters? Yes, as we know, it has 1,000 meters. An hour has how many seconds? It has 3,600 seconds. So to change from one unit to another, first you have to follow steps. Step number one, you have to define which one is the large unit, kilometers or meters, which one is the small unit, hours or second. And then if you're going to change from the large unit to the small unit, you have to multiply. If you're going to change from the small unit to the large unit, you're going to divide. For example, here, I need to convert 200 meters to kilometers and use the unit kilometers instead of meters. What we are going to do, we know that each kilometer has, or 1 kilometer equal 1,000 meters. Here, what is the small unit? Meters. So we are going to change from the small unit to the large unit. So we are going to divide. Let's do it here. We are going to change from 200 meters to, or use the unit kilometers. So we know that 1 kilometer equal 1,000 meters. Then the second step, we are going to multiply or divide here. Yes, we are going to divide because we change from the small unit to the large unit. We are going to divide 200 divided by 1,000. So it's going to be 0.2 kilometers. This is how we change or convert the values or the base units, by dividing or multiplying. And we have to know first how many or which one is the large one or the small unit, and how many kilometers or how many meters in 1 kilometer.